Everyone, welcome to my channel. So in this video I'm going to explain how we are going to solve this problem called the combination sum 3. So let's first read through this problem. So find all the valid combinations of k numbers that sum up to n such that the following conditions are true. So only numbers from 1 through 9 are used, and each number is used at most once. So return a list of all the possible valid combinations. The list must not contain the same combinations twice, and the combinations may be returned in any order. So let's see the first example. We want to select 3 numbers from 1 to 9, no duplicate numbers, and then it should be sum up to 7. So there is only one possible combination, which is 1 to 4. So let's go through this piece of code, and at the same time I'm going to explain what the general solution is. So the general solution is to do recursion plus backtracking. So essentially we need to enumerate all the possibilities to get k numbers from the 9 numbers. So let's see. First of all, we have a list of the results. So this result is the final thing we are going to return. And this one, the temp integer list, it is to store the temporary result we are potentially going to insert into the result. And then we define this helper function, which is a recursive function. So let's go through this one. So the first one is the starting number we are currently looking at. So it is within the range from 1 to 9. And this one, it is about n, which is this n, minus the sum of all the numbers from the temp list. And this remain count is k, which is this k, minus the length of temp. And and we also pass in the result. So when remain sum is equal to 0 and remain count is equal to 0, that means we already find a combination of k numbers that sum up to equal to n. So we are going to add the temp list, which stores the k number sum up to n into the result list. If the remain sum is smaller than 0 or the remain count is smaller than 0, then it means it is already overflowing. So we just simply return. And then we go to this for loop. So essentially, for the current position, we have those different options here. So we have remain sum. So when the remain sum is smaller than I, there is no need for us to go over the rest of it. That's because anything comes after this number should be also larger than remain sum, so which is not going to give us any valid answer after that point. So we just break it. Otherwise, we will add the current I into the temporary result, which is the current number we are looking at, and then call this recursive function. So this is I plus 1, which is the next number we are looking at. And this one is because we already added I into the temp, so we need to deduct it from remain sum. And similarly, we have one number included in temp, we need to have remain count set as -1. And then we also pass in the temp and also the result list. And finally, after this one is returned, we need to do backtracking. So we need to remove this I added into the temp from this temp list. So that's essentially how we solve this problem. So the runtime, is going to be something like, let's say we have 9, so it is 9 divided by. So this is 9 divided by. So k times 9 minus k. So essentially this is how many combinations are there, how many combinations from the 9 numbers we choose. So how many combinations we choose k numbers from 9 numbers. So this is all the possibility, and potentially if every combination is the result, then we need to add the temp result into the result list. So this one is going to take all of k. So we are going to have this I don't multiply on top of it. So the runtime overall, it is going to be something like this. And regarding the space, if we consider the result, the size of the result, then it is also going to be this. But if we just leave it alone, then the space wise is going to be constant, because or we can say it, because we have at most 9 numbers, we can add to the temp list. Otherwise, if we don't consider, yes, and otherwise we can also say it is all of k, because at least the length of this temp list, it is at most the length of it is no more than k. So either constant or okay. But for this, but that's the case. We leave the space for the result we are going to return. If you include this, as I said, the space is going to be something like this. So that's it for the solution for this question. So if you have any question about the solution, feel free to leave some comments below. If you like this video, please help subscribe this channel. I'll see you next time. Thanks for watching.